Hello, everyone, and thanks for joining us. This is Robin Duke-Woolley here. I'm the moderator for this session, 5G Fact versus Fiction, and how LoRaWAN plays a role. So we're going to go through this agenda over the next hour. So I'm doing the introductions now, and I'll do a short market overview. And then we'll have a section on LoRaWAN, filling a market gap, enterprise, wireless convergence, mobile operator, wireless convergence, and then multi-service operator, wireless convergence. So we have 4 speakers for those sections, then a summary, and then we'll have a Q&A session after that. Now, in the Q&A, we'd like you to send your questions to us so that we can respond to those, and we'll pick up as many as we can at the end. There are a large number of participants. We hope to get through as many of the questions as we possibly can. So just to introduce us all, my name is Robin Duke-Woolley. I'm the CEO at Beecham Research, which is an analyst organization that I founded many years ago, focused on the IoT. If I could then introduce our presenters. First of all, we have Remy Lorraine, who is Director of LoRaWAN Networks at Semtech. Great to have you with us, Remy.
Thank you, Robin. Glad to be here with you guys. More than 500 people, it's nice.
And next we have Daniel Quant, old friend from MultiTech. So Daniel is Vice President of Strategic Development at MultiTech. Great to have you with us, Daniel.
Yeah, thanks, Robin. Pleasure to be here this Monday morning from the US.
Great. And then from Charter Communications, a big cable company in the States, we have Wael Giben, Principal Engineer and Technical Director for Wireless and IoT. Great to have you with us, Wael.
Thank you. Great to be here.
And then from Orange, we have Ronan Lebras, who is Head of Technical Strategy for Wireless Networks and IoT. Great to have you as well, Ronan.
Hello, good afternoon, and thank you for inviting me to participate to this webinar.
It's great to have you with us. Okay, I'm just going to say a few words of key points for market overview, and then I'm going to hand over to Remy, who's going to take us into more detail. So what I would say is that there are more connectivity choices in the IoT market today than ever before, and this is a really, really good thing. It's important for market development that there is competition, both within technology types, but also across different technology types. The more technology types, the more options that people have for applications, the better. We end up with more applications connected in the IoT that way than if there are limitations. Now, for those of you like me that remember back in the old dim and distant days of M2M, when M2M started, we talked about 2G cellular. Actually, it was 1.5G. It was GPRS, if you can remember that far back. And that limited scope for applications. There was only a relatively small range of applications that costed in, if you like, at that time. And with more choice came a much wider variety of application opportunities, to the point now where we have lots of choice. And that's increasing all the time as new connectivity types have come along. And that's obviously a good thing. So in particular, Beecham Research, my company, has been working with the IMC, the IoT M2M Council, on connectivity guidelines for different IoT use cases. And 2 participants, Semtech and MultiTech, 2 participants of this webinar, are also members of the IMC. But we, as part of that work, evaluated connectivity requirements for over 80 use cases in 9 different sectors. We probably extend that to well over 100 by the time we finish the work. And what we saw at the time is that clearly 5G is at an early stage. It doesn't cover anything like the full market, and it's not likely to for several years. We have 2G, 3G reaching end of life. 3G probably sooner than 2G, but nevertheless, they've not got a substantial future. And then we got 4G growing. But that leaves a huge opportunity for unlicensed technologies, in particular LoRa and LoRaWAN. So that was the work that we did in our own connectivity guidelines. But there appears to be a myth in the IoT market that 5G covers all use cases. Well, that's just not the case. I don't know quite where that myth came from, but I have to say that this webinar is going to debunk that. We explain why 5G only, in fact, is a wrong approach to IoT market development. It would tend to limit market growth and would set us on a path we think that would not be very helpful to the overall IoT community. But at the same time, I would say that it's never been more important for IoT users to decide the connectivity required for an IoT project at an early stage. I was surprised when we did our own study in this area how often that's not happening. So for example, we get quite a lot of IoT users have the impression that IoT connectivity is a mere commodity requiring little planning. I would have to say that that's a dangerous assumption, a very dangerous assumption, leading to many project failures in the past. And in fact, we have issued a free report, which is downloadable from this website, whyiotprojectsfail.com, that explains why that is a dangerous assumption. So if you are interested and would like to know more, then that report, it's a 100-page report. It's all full of research, and it's freely available to download at whyiotprojectsfail.com. So having sort of introduced that and the fact that we're going to look in particular at why 5G only is not a way forward for IoT, I'd now like to hand over to Remy at Semtech, who's going to fill in some of those gaps to take it forward from here. So over to you, Remy.
Thanks, Robin, for setting the overall context. So let's now position LoRaWAN into the 5G ecosystem. Let's start from the GSMA use case segmentation. Here you have three types of use cases. In green, the critical communication, which require low latency and high throughput for critical needs. Next, you have the enhanced mobile broadband, like immersive video. The most important things here is to have a seamless experience with high throughput. And last but not least, the massive IoT, the massive deployment of sensors at very low throughput and no latency constraints. It may represent more than 80% of the market. Let's look at the critical and broadband segments. They will rely on 5G. People talk about the 5G new radio. It's about low latency and high throughput. Regarding the massive IoT, where, of course, LoRaWAN is a strong contributor, it relies on 4G. Robin, that's a first myth. It's not 5G, but 4G. It's regarding LTE and narrowband IoT. So it's mainly an evolution of the current 4G technology. Finally, when you look at the massive IoT bubbles, where LoRaWAN plays, every technology has its own market. Even if you have some overlapping use cases, both technology can be considered as complementary, and I will develop in the next slide. Let's now look at the massive IoT market share, or people like to call this market low power wide area. So when I say LPWA, it's the same as massive IoT. Today, LoRaWAN has clearly become a de facto unlicensed standard and leads the LP1 market. Just to say that you have LoRaWAN networks in 157 countries, supporting 135 million end nodes, where narrowband IoT, for instance, is around 100 million units, mainly in China. So LoRaWAN has a wide ecosystem, and the LoRa Alliance represents already 500 members after 5 years of existence. Most analysts today expect that in the next 5 years, cellular IoT and LoRaWAN will lead the market and may represent up to 80% of the LP1 connections. So we often have the question about LoRaWAN and cellular IoT comparison. You see multiple complex technical analyses on the web, which are more confusing than anything else. The comparison is not only technical. Let's make it very simple. On the one hand, LoRaWAN has been designed ground up as a LPWAN technology to meet specific massive IoT requirements. The top three strengths compared to cellular IoT today are the fact that the thousands of public and private deployments are moving forward and going on. It's about the business model flexibility or the make or buy. It is also an ultra low power technology. Of course, it's been ground up designed to be power efficient. And you cannot imagine changing your batteries on billions of devices on a regular basis. And finally, the cost effectiveness in terms of rollouts, nothing to compare with a cellular network expansion, for instance. So the tens of mobile network operators using LoRaWAN today agree on these three main strengths in a way compared to cellular IoT. On the other hand, cellular IoT has very strong strength in the area of critical application, ability to guarantee low latency, ability to guarantee high SLAs, but you have to pay. You have to pay in terms of cost. You have to pay in terms of power. So I won't say that one is better than the other. Of course, there is a perfect match if you use both of them. So they are complementary technologies again. So let's move now to the fact and fictions, because that's the name of the webinar, right? Everybody talks about 5G. Everybody talks about LoRaWAN. But it's nice today to clarify four of the myths that we hear every day when talking with the market. The first myth is that 5G covers all use cases. As Robin introduced, it's wrong. 5G new radio is focused on broadband, but massive IoT is not 5G, but 4G. Of course, going to interconnect with 5G. The second myth here is that only 3GPP technologies connect to the 5G core. It's completely wrong. Mobile operators already interconnect LoRaWAN at the data management layer. Other interconnection routes are under investigation, and Dan will develop on that. And of course, that's the DNA of 5G core to set up interconnection functions with other technologies. The next myth is that 5G covers everywhere. Even 4G is not covering everywhere nationwide today. The 5G investment will take years because it's not for free. And operators still need to find the business ROI for this new technology. So it's wrong to say that 5G will cover everywhere on the short term. The last myth that we have today is that 5G and other IoT technology will not coexist. I could say that another way, 5G is going to eat other technologies. It's completely wrong. It's not what the market says today, because the market trend is a multi-radio access network strategy where you use the best technology for the best use case, assuming that today at the data management level, you can easily interconnect any technology. And it's going to be the occasion to hand over to Dan, which gives a first example of a multi-RAN strategy on the enterprise market. Dan, I'll let you the mic.
Thank you, Remy. So MultiTech has been assisting enterprises deploying and managing their own networks since mainframes, PBXs, and the birth of the personal computer, with many having extensive wireless experience going back decades, such as oil and gas, utilities, and transportation. Over the last 5 or so years, LoRa, low power wireless access deployment agility has certainly met the pent up enterprise demand to deploy and manage dedicated networks. Networks that enable enterprises to connect more assets and accelerate their digital transformation. That Wi-Fi incubated with increased worker productivity. We also now start to see cellular jumping in here too. Why do enterprises deploy and manage their own dedicated networks? Well, it's simple, really. It's all about reliability, security, performance, and control. Most enterprises have their assets clustered inside the facilities and the buildings where they work, their HQs, their refineries, their facilities, or they have those assets in their customers' facilities. And they want to be able to make sure that they can get their best total cost of ownership in connecting these assets. And so by doing so, they move that business model a little bit more towards a capitalized investment. And they do that so that if they connect 1,000 assets and then today they have one more asset to connect, they don't have to pay a subscription charge for that one asset every month for the life of that asset. Instead, they own more of that network as a capitalized cost. But it's really about the performance. It's about making sure that the network is there for the applications. Instead of a network being there for most applications, at most places, for most reasons, instead designing an enterprise network that's born out of a very known set of applications that are then connected into those networks, making sure that that network is always there with the right kind of quality, deterministic quality of service, greater resilience to downtime, and just essentially making sure that that asset is always connected and provides the best customer experience or data continuity. And of course, it's also about privacy. It's about making sure that that data doesn't unnecessarily leave the domain of the enterprise, perhaps remains on-premise, and perhaps stays in a geopolitical region for that data. So enterprises are starting to realize that, that they need to be focused on radio access technology that is standardized, either by an industry association that makes that standard open, that then fosters a large ecosystem of vendors to come in and be able to build technology that meets that need. They're looking for all IP connectivity in many cases. They're looking for a technology that has perhaps a more industrial IoT architecture where it's more device and sensor to the network directly to the cloud, rather than complex SCADA-based applications and other complex systems that have been in play previously. And with that larger ecosystem, of course, comes broad access to connectivity and at a better cost point. When you look at those wireless KPIs, you see the latency, the broadband data bandwidth that 5G brings, that low jitter. You can get on that channel whenever you want, and you get that mission criticality. Of course, with sensors and large-scale, massive IoT connectivity, it's really focused on that capacity, the range, the battery life, and getting that cost down so that perhaps sensors and connectivity can be brought in at sub $100 pricing. And as you see, these KPIs fly in the face of each other. They're completely different. It's a tale of two cities. And so for this reason, 5G era, in this 5G era, 3GPP, 5G new radio won't eat all other radio access technologies. It can't. It's designed for applications that require low latency, enhanced broadband data, And looking ahead, mission critical connectivity, not so much for battery operated sensors on motors and pumps and hydraulic fluid and compressed air, that's there to improve process automation with prescriptive maintenance and what have you. So this is a great example of how the enterprise is leveraging those KPIs in order to get the best of both worlds, get its cake and eat it. It's using cellular technology like 5G in order to provide a wireless fabric connectivity, a wireless fabric that covers their facilities, their oil fields, their campuses, their buildings. And with that, handsets and voice communication, mobile apps, they can natively connect into that cellular network. Assets like pump-off controllers here at wellheads, they produce a lot of data. And so that kind of asset can be directly connected into that cellular network. But that 5G network can also be used to create tributary networks or secondary networks. That could be Wi-Fi to aid in worker productivity with tablets and computers and what have you, that are broadband type assets, but also to create connectivity for LoRaWAN sensors. And by doing so, really leveraging those KPIs. So you've got that low latency broadband connectivity directly into the gateways and the routers, but then you're creating a front haul technology, a tributary network that's more suited, better suited for the applications that it's connecting. Essentially, it's about the enterprise realizing that it's the right radio access technology that best connects their applications with their needs in the locations in which they're situated. Essentially, LoRaWAN being the perfect trade-off between range and battery performance. So enterprises have already begun interconnecting their data and their networks. Many large enterprises and medium-sized small enterprises have all made a decision to common their data aggregation, their data lake, if you like, with a specific IoT data platform. Many have gone with Amazon or Azure or IBM. The more industrial companies have focused on platforms like Ignition and OSI Soft Pi platform, but they've made their decisions. They've made their decisions where their data is going to be aggregated. And that means that whether it's a wired or a wireless network, all of that data can come into a common place. The enterprises have now started to focus, as the previous slide showed, on how they can leverage those best KPIs of a radio access technology, perhaps using 5G as mission critical backhaul, but using LoRaWAN to find that perfect trade-off between range and battery power. A lot of these assets and sensors are now sending data through to the application layer using semantic layers like lightweight M2M or structured data preparation and publish and subscribe models that disconnect the vendor lock-in between the assets at the edge and the data platforms upstream. And MQTT is a great example of that with open SCADA techniques like Spark-Plug-B, where every asset and every tag within that asset is associated to a pre-structured amount of data. And that's super important because that means that years into the future, that data can be looked at by an application and the application knows exactly where that data came from and what the value structure of that data is. And it's also interesting to see that now enterprises are looking at their core networks as well. Under investigation now is SCEF and NEF interconnection, which would provide mutualized security, would enable non-IP IoT traffic to be routed to its particular application servers. So in a nutshell, enterprises are learning how to leverage a radio access network's best KPIs in order to converge their network architectures. 5G era interconnect is more than just 3GPP 5G new radio, and LoRaWAN has established itself as and led the LPWA massive machine connectivity revolution, and is now a staple in enterprise RFPs. Thank you.
Yep. Good afternoon, everybody, or good morning, depending where you are. So I'm Ronan Lebras from Orange, and I will describe how we integrate LoRaWAN in our strategy alongside 5G and cellular solutions. So we are a strong advocate of the multi-access strategy as far as IoT is concerned. So for us, we have a very diverse portfolio already. We started based on the strength of our cellular network with 2G M2M, as was said earlier by Remy. We introduced LoRaWAN in 2016 in a group, especially with a nationwide deployment in France, and I will explain why. We then also introduced LTE-M networks, which is one of the two versions of the cellular IoT solutions in 2018 in some countries, and I will also explain in where and why. And we're already looking at 5G testing with several trials and upcoming deployment this year. So the reason why we are advocating multi-access technology is that we do believe that there is a segmentation by the usage, and that in fact not all technology are equal. And we at Orange selected a combination of LoRaWAN and LTE-M because altogether they cover the widest range of use case. LoRaWAN is very pertinent and very strong when battery is constrained, and that's a lot of use case around metering, so water, gas, for example. A lot of use case in the building, so smart building application, where sensors are put for several years and they will not be changed, and battery will not be changed for several years, so they need really a long battery life. And also LoRaWAN is strong as a backup for other technologies. So for telealarm, for example, it's often used as a backup to cellular solution to avoid jamming, for example. And one of the other use case that we've seen where LoRaWAN is quite strong is industrial asset tracking. So here we're not talking about fleet management, but it's more to locate machine, heavy tools that will move at some point during a month or a week and need to be located, but with again a battery constraint because the device might not be powered all the time. And on top of that, LTE-M is more viable and the right solution for use case requiring more two-way communication, more frequent sending of message. So for example, electric metering is a good use case for LTE-M. Some amount of tracking when they are more linked to people or to animals, for example, vehicle tracking, object tracking. And so we believe that the combination of those two are really able to provide us the widest range of covering for the use case, and it's not overcomplicating we do not add several layers, only with two technology. We think we covered most of the use case. To confirm what we've done as far as LoRaWAN is concerned, we've deployed a nationwide network in France since 2018. We started in 2016. It's fully nationwide since 2018. 95% of population covered. Now more than 500 business customers use our networks. And the biggest and the key use case we have is on smart water metering with large utilities that we signed a contract with to address 3 million meters for the next 10 years. And a lot of other use cases are around metering and a few around smart cities as well. So it shows that if you go with a wide area network like covering the full countries, you can have large deals where local deployments will not be enough. And on the right, we have a situation of other countries where we are present in 7 countries in Europe, but not all of them have adopted the LoRaWAN for now. So we have targeted deployments in Slovakia and in Romania, where we only deployed to answer to some use case and customers. So in some dedicated deployment, could be a city-wide deployment, industrial site deployment, or even building deployment. So in those 2 countries, it's mainly smart cities type application. So for example, in Romania, city of Alba Iulia, where LoRaWAN is used for smart lighting. But in Slovakia, it's also smart parking application and smart buildings. And in that case, we only deployed where the customers want the sensors or the devices to be connected. So it's a different approach to the one we've adopted in France. And it shows also the different requests by customers. In some countries, they want devices to be connected everywhere. In others, we have customers who only want on-the-spot coverage in a certain location or in certain cities, but they do not really care about the full countries. So different approach, and that's a flexibility of LoRaWAN that we do not have, for example, with cellular for now. So we are also looking at other POCs for LoRaWAN. You will hear maybe in the next few months about them, but that's all what is currently public. And in terms of overall LP1 deployment, so apart from those LoRaWAN deployment I've named, we also, of course, as a mobile operator present in 7 countries in Europe and 28 in especially in MEA and Africa, we have adopted LTE-M in most of our affiliates already, and in Belgium they also have adopted NB-IoT in addition to LTE-M, because for some markets request over there, NB-IoT was requested for some large tenders, so they deployed NB-IoT rather than LoRaWAN. But usually the trend has been that we've pushed for LTE-M, and LTE-M has some benefits in terms of roaming. So we've already announced a commercial agreement for roaming with LTE-M with several operators, including North American operators, European, and so LTE-M roaming is now a reality in Europe. What is important is that for Orange, not only we are an operator, so we provide connectivity layers, so we provide multiple connectivity layers, so LoRaWAN, but also cellular, LTE-M, and IoT, 5G is coming, and others, non-cellular also. But what is important is that we provide a fully integrated solutions, and for some customers, we can go on top of the connectivity. We provide the IoT data management. So we have a platform called LiveObject, and on top of that, we provide some dedicated services, bespoke, for certain verticals, for fleet management, smart tracking, and smart operation. And also we can do specific implementation for some customers based on other third-party integration and development. So we have a very flexible approach. So whether customers only want the connectivity or want the full suite, we can provide. We believe that we are now a digital integrator and not only an operator. And coming back to the LiveObject, the platform that we have, IoT platform, so it can already talk to cellular devices and LoRaWAN devices. We have some APIs that allow the customers to be able to get his data, whether they are coming from 3GPP or non-3GPP solution. So the integration, the interconnection is already done at this level. You see LoRaWAN and the 5G living together, and we believe, first of all, that yes, 5G is coming, but for the massive IoT, it will be first based on LTE-M and NB-IoT evolution. So they are 4G radio interface for now, but they are going to improve with release 15 and release 16. And in fact, they will reach the 5G KPI that were set by the ITU, and that 3GPP has worked against. So they will become, let's say, 5G technology. And from the release 16, it will be possible to connect those 4G radio to a 5G next generation core. It's not currently the case, but from release 16, which is maybe 3 to 4 years from now. And in parallel, we strongly believe that LoRaWAN is the right technology for the LP1 use case where battery is really a key constraint, because for now, we believe that the protocol is much lighter in terms of energy consumption, and also, and we've seen that in the European countries where we work, but also in others where we are doing POC, it's very easy with LoRaWAN to do ad hoc deployment for a specific customer, whether it's within a public networks or private networks. And it's a very key asset for LoRaWAN, and that's why we believe that it is going to continue. And we are working within the Alliance and with some partners to try to interconnect even more LoRaWAN networks to 5G. So currently, it's at the data management layer, as was shown earlier. But we hope that we will be able to work also maybe at another layer, maybe a bit below at the core network level, like was shown by Daniel a bit earlier using SCEF and NEF. So thank you very much for your attention, and I'll pass to the next contributor.
Thank you, Ronan. I guess due to the international nature of the attendance of this webinar, maybe I'll present briefly who Charting Communications is for people outside of the US who might not know about us. So here in the US, we are a leading broadband and connectivity company. We serve nearly 30 million households spread over 41 states, along with serving SMEs, larger businesses, government. We also serve today over 1.1 million cellular customers in our footprint with our recently announced 4G and 5G networks through our Spectrum Mobile brand. But let me, I guess, dive into the kind of technical aspect. So I'll start actually with the radar view of technologies on the right side here, where we're trying to map the design and deployment KPIs for different technologies, from the geographical coverage to the solution deployment CapEx and OpEx, to the device power consumption, and all these, I would say, KPIs you're looking at here. And if we take, for example, the case of LoRaWAN, it is clearly falling within the LP1 technology space, and it actually is a leading technology within that segment. As for example, as recent as 2018, it was counting for 50% of the LP1 deployment worldwide and growing. It is a great technology for battery-powered devices that tend to come at lower solution cost, longer battery life, and asymmetrical application requirements, in the sense that the uplinks or the device uplinks are larger than the device downlinks, where you only require every now and again acknowledgements or firmware upgrades and things like this. Also, we from mapping the cellular technologies from KPI perspective, it is actually most suitable for delay-sensitive communications and applications requiring a greater, I would say, quality of service in terms of throughputs, in terms of availability, and it's the front runner for applications within the IoT segment, for applications like audio, video, telephony, all these, I would say, classic applications. So what we learned deploying 5G and 4G or 5G and LoRaWAN solution is that there is no solution that fits all. In that sense, I guess the winning technical strategy is to be access technology agnostic and to adopt a multi-RAN strategy, where cellular technologies are designed and more suitable for mobile broadband, delay-sensitive communication, mission-critical networking, and LoRaWAN is deployed as an LP1 for devices that require and deliver 5+ miles, 7 to 10 years of battery life, and is mainly suited for scenarios like smart agriculture, smart cities, parking management, smart metering, smart lights, where devices tend to send infrequent data at low data rates with lower payload sizes. I will actually give an actual use case or scenario where a multi-RAN strategy is the winning strategy to solve a real use case, I would say, and a real customer pain point. So here we're looking at actually the parts of connectivity solution that made it possible to connect a 250 acres of land with different IoT sensors, moisture, temperature, presence detector, door and gates monitoring systems, GPS trackers, and air quality monitoring for hog houses, all connected through LoRaWAN, because the requirements from these applications were fitting the LPWAN and the LoRaWAN KPIs. And 5G was used mainly to provide the broadband connectivity through fixed wireless access, through Wi-Fi point-to-point, and the usage of 5G NR in C-band and in 5 gigahertz band, I would say also known to many of you as NRU or NR and license. So this is to provide the backhauling from, I would say, from a hog house to a hog house, or to serve, I would say, more data-intensive devices like HD cameras, 360-degree cameras, and thermal cameras, where we are monitoring, for example, over 10,000 hogs, looking at their feeding times, looking at use cases where, for example, we can alert in real time the deaths of hogs, and we can, I would say, remove them from the, in order to not affect other livestock. Here also we're using 4G as we see there is a 4G connected drone to give the farmer and to give the user the capability to tour and inspect the farm at any time. And I strongly encourage you to follow that link to be able to understand a bit better the use case and the outcomes of it. Here, just I would say some visuals from the actual development and deployment, where we look at, I would say, the on-premise eNode B and core network providing the main 4G and 5G connectivity in licensed and license-exempt bands. We're also looking at the data presentation aspects, where all data is presented in real time to the farmer as the drone navigates the 250 acres of land. So we're merging actually the data captured by LoRaWAN devices with the real-time video stream and video analytics enabled on top of the 4G and 5G backhaul cameras and drone. Again, the point here is to kind of join what Ronan and Daniel were saying, that the data presentation layer and the data layer can be a layer of convergence of 4G, 5G, and LoRaWAN. And this is I would say, a layer where they can connect. And to the point that actually the other speakers made, we're also working on other kind of at core and below the core, I would say, interconnection options. Again, just to recap and conclude on that particular use case, so the multi-RAN strategy, or we may call it the access agnostic, I would say, strategy, enabled us to successfully solve this particular use case for connecting 250 acres of farm and monitoring 10,000 hogs through the usage of LoRaWAN and 4G and 5G, where we looked at, I would say, connectivity as a service to the use case, where we looked at this use case requirement and KPIs, and we derived the right technology from there. And naturally, I would say 4G and 5G were deployed for the delay-sensitive communications, the backhauling, the broadband applications, and LoRaWAN was the technology we selected to for all these sensors and actuators that we talked about a bit earlier. So here I'm giving our perspective on as an operator on LoRaWAN. It became to us clear today that LoRaWAN is an industry de facto standard for LPWAN, solving a variety of use cases. It is a proven carrier-grade networking protocol, offering secure end-to-end communications, secure hardware and software components, and standardized and secured interfaces. A very interesting point is the fact that LoRaWAN is built on top of sub-gigahertz ISM license-exempt spectrum, which removes the spectrum, I would say, ownership barrier of entry to the deployments, where we don't actually need to own spectrum to deploy. We just need to abide by the regulations. For example, here in the US, FCC 915, I would say, regulations. In Europe, 868. And we have, I would say, regulations captured for all within, I would say, the LoRa Alliance for all applicable regions. And this is, we see it as a technology that gives us the ability to rapidly build and deploy scalable networks that are dedicated to LPWAN and that run alongside 5G and 4G networks to serve, I would say, the all the use cases we look at.
Thank you, Vael. Let me summarize what was said in this insightful presentation. Robin first introduced the market trend to play with multiple IoT technologies to serve all use cases. Then we positioned LoRaWAN and cellular IoT, 4G, 5G. We also clarified key 5G myths and facts. Dan, Ronan, and Vael illustrated the multi-radio access network strategies involving LoRaWAN and 5G as an enterprise, as a mobile operator, as a cable company not owning licensed spectrum, but it was the same story, right? So what are the key takeaways here? First, 5G is definitely an opportunity to scale critical and broadband applications. Next, LoRaWAN and 4G complement to serve massive IoT use cases. LoRaWAN is positioned as a de facto unlicensed standard, and the market anticipates that LoRaWAN and cellular will lead the market in the next 5 years. And we can say that operators, vendors, and enterprise are rapidly developing multi-RAN strategies involving 4G, 5G, LoRaWAN, Wi-Fi, and other technologies, because we are also an open standard. And let me now hand over to Robin for the Q&A session.
Great. Well, thanks very much, Remy. For those of you that are interested in statistics, you might like to know that there are nearly 700 participants on this webinar. I counted a peak of 680, but it's been going up and down. So we are testing the technology, I think, at this time of COVID. But let me move on to some initial questions then. So first of all, is there a private LTE impact on LoRa? Now that's something I think that Daniel might be able to help us with from his MultiTech days.
Yeah, thanks, Robin. So yeah, the impact on LoRa and private LTE is much as I highlighted with the combination of those KPIs. LTE brings low latency, high broadband, mission critical type connectivity with a more heavyweight protocol stack that has been designed from the ground up to address that type of need. Whereas LoRa has a very lightweight stack that's designed to connect sensors and simple devices on batteries for years at a much lower cost point. Both to buy and to operate. And so by mixing the two, you have the best results. I mean, we've sold and shipped 20% plus of the number of LoRaWAN gateways into the market, and probably 80% of those had cellular backhaul to them.
Very good. Yes. Does anybody else have any thoughts on that?
One additional point is that usually the private LTE networks are built on higher frequency, so 2.6 or 3.5 gigahertz band, and as will be also some private, maybe 5G networks in the future. Well, LoRaWAN for now is sub-gig technology, usually in 868 megahertz or 915 megahertz in some countries. So the range is quite good at that frequency. So I think private LTE, in addition to the fact that it's targeting other type of use case, it will also have a lower coverage range than LoRaWAN.
Super. Thanks very much for that additional thought. So the next question is, to what extent do you see network operators using LoRaWAN? Now, I could ask Ronan, but he's from Orange, so he's just been speaking. So I think I'd address that to Remy from Semtech. He might give a broader view of that one. Remy,
okay, thank you, Robin. So not many people know that the LoRa Alliance was kind of founded also by European mobile network operators that Orange was part of, but not only. We can also name Swisscom, KPN, Obgenius, Proximus. Other operators in the world, big ones, use LoRaWAN, like NTT, like SKT in South Korea. We estimate today that around 30 mobile network operators use both LoRaWAN and 4G, 5G. And the real number is probably bigger because not all mobile network operators disclose the fact that they use LoRaWAN. So there is a good trend, but it represents not more than 20-25% of global operators because we have a high diversity of operator types.
Okay, that's great. The next one is how can we compare firmware over-the-air photo for NB-IoT versus LoRa? Is multicast necessary for efficient photo, and is multicast easy to implement on a LoRa network? Dan, would you like to respond to that?
Yeah, the multicast strategy is now defined in the LoRa Alliance for LoRa, and with frame concatenation and group policy management, and the enterprise can schedule firmware updates across a single device or a wide range of devices, and it's efficiently delivered both to the radio of the device itself, but also to the host application behind that. So been big strides in standardizing that over the last couple of years.
Is that multicast or not?
Yeah, using multicast, absolutely. It's by far the most efficient way to reach that number of endpoints with the lowest battery budget.
Okay. There is then a question about comparing security between LoRaWAN and NB-IoT. Is there a comparison between LoRaWAN and NB-IoT for security? And the comment here is eSIM seems to be more efficient, perhaps, but there might be another view about that.
Well, I'll kick that one off, Robin,
okay.
with what's the difference between an eSIM and a secure element with secure key root of trust?
I think that's right. I think that's probably.
I mean, it's one and the same thing, isn't it? One of the things I would like to bring up, I don't want to get into some sort of contest about which technology is the most secure, but just highlighting that the SIM offers a very secure paradigm for cellular communication, but that's really all about securing data between an asset and the base station and an asset and the APN. Whereas LoRa has two keys. One does that network level, but the other key is for the application layer all the way to at rest in a application server, which you don't typically tend to find in cellular unless you implement another layer of security like TLS or certificates or what have you.
Remy, do you have a view on security of LoRaWAN versus NB-IoT?
Yes, I think that people like to compare technologies regarding security, but the real security insight is not into the technologies. It is how you store your keys. It is how you exchange your keys securely. It is whether or not you have some hardware secure element on the device side. It is whether or not you have a secure element on the cloud side. So the security performance is not linked to the technology. Both technologies have everything to meet high security performance. Right. It's how you implement your process. So for me, it's a wrong question when you look at technologies.
Okay, all right, yeah, that's great. Well, you've just got time for one more question, which is 5G NR Lite will address massive IoT in future. Will this impact on LoRaWAN in the future? Remy, perhaps that's also one for you.
Yes, but if you heard what Dan said, so the LR Lite, the new radio Lite is going to be, or Renault I think, is going to be specified or is specified in release 17. It means that you will have it on the market by 2 to 3 to 4 years, then real commercial development in 5 years. So the main advantage to get that, it will prevent to get 4G and 5G technologies. But at the end of the day, you will come up to exactly the same comparison that we said today. You will still have the strength of cellular IoT for high quality, low latency application, and LoRaWAN will have progressed also. And I think it should be similar in terms of business and comparison analysis. So it will not change a lot to me.
Okay. Any other comments
Yeah,
from?
Just to add on this, the NR light, the KPI for the NR light are still aiming at, I think it's 100 megabits.
Okay.
Is the target. So it will be a lower class, let's say, for a 5G device, but it's still a very, still a very high capability type connection. So it's nothing like a true LP1 connectivity with which is aiming at a few hundred kilobits, maybe maximum, and even very low throughput when in cell. So we are really not going in the same, let's say, direction. It will have a use for IoT, but more for maybe wearables or low-cost type modem, but it's not aiming at the LP1 use case.
Great. Okay, that's a very good point. I think you'll all agree that there's been a lot of information provided on the webinar, a lot of slides we've certainly gone through. Those will be available for download. They'll be available from Semtech. I'd like to thank you all for participating, and also the speakers for participating as well. Very good session. In these days of lockdown, it's useful to have these sessions. So thank you all. Keep safe, everybody, and have a nice day. Bye for now.